When mixing two solutions, if an actual chemical reaction is happening, you will be able to identify that a chemical reaction happened by observing what is happening in your mixture. So if the temperature is changing, sometimes that means that it's a physical change, but sometimes it means that you have an actual chemical reaction happening. If you were able to detect a temperature change during this experiment, then it means that an actual chemical reaction happened. If you have formation of a solid means that a chemical reaction happened, and the type of chemical reaction that it's happening, it's a precipitation reaction. The solid is precipitating out of your solution. Change in color means that you had a chemical reaction happening. Sometimes when you have a precipitation reaction, the solid that it's formed will have a specific color, and that's a change in color, not in your solution, but you can actually observe the solid forming, and the solid can be white, yellow, orange, depending on the actual compound that you have. You can see the color for your solid. Another thing that you can use is a change in odor. So if you can actually detect an odor, it means that a chemical reaction is happening. So those are the things that you can use to identify based on your observations to say if a chemical change is happening. Now, if nothing happens, if you don't get to see a solid forming, color changing, a gas forming, which is another one, if you see bubbles forming, it means that the gas is forming while the chemical reaction is happening. So if you don't observe any of those, like formation of a gas, change temperature, formation of a solid, that means that whatever you're combining is not giving you an actual chemical reaction. So nothing happened. If you didn't have any observations, you can write down no reaction. For the reactions that you actually have observations that something happened, you need to write down the products of your reaction. You're going to predict the products based on what you're mixing, which is your reactants, and your observations. Besides writing down the products of your reaction, you need to write down also the coefficients. Once you balance the reaction, you need to add the coefficients. And you need to classify your reaction as a specific type. If it's a single replacement, combination, or synthesis, if it's a decomposition, if it's a double replacement or double displacement, you need to actually write it down in your report. Now, how to write down the products of a chemical reaction? I'm going to give you some examples, and then you can apply the same things that I'm doing here to complete the products of the reactions that you have. So when you're writing the reactants is what you're actually mixing. So this first reaction that I have here, my reactants are sodium carbonate and barium chloride. If that's the case, it means that I'm mixing my solution of sodium carbonate with my solution of barium chloride, combining them and checking for my observations to see if an actual reaction happens when I mix these ones here. So to write down the products right here, I'm going to look at my ions. These are ionic compounds. You have sodium, you have barium, both metals. So you have your metals combined with negative ions, giving you ionic compounds. So I have my positive ion here, and look how I'm underlying just the ion. Is Na, not the 2. The 2, it's a subscript, just the ion. And now on my other compound, I have the positive ion is barium, the negative ion is your Cl. So I'm going to underline my Cl. The positive in my first compound is sodium, the negative in the second one is the Cl. If the ions exchange between your first compound and the second one, the Na goes with the Cl. So I'm going to write down just the ions, okay? Just the ion. You don't carry any subscripts from reactants to products. So I'm not writing down Na2. I'm not writing down Cl2. I'm writing down Na and Cl. So that's my first possible combination, the positive with the negative. And now I'm going to check the other two, remaining two. You have the negative here is the carbonate ion, the entire thing. And the positive here is the barium. So that will give you a second combination of ions. So you're actually exchanging them. So my second combination, I'm going to write down Ba and CO3. No subscripts, nothing, just the ions that you have. Now you're going to check if you need to add any subscripts to your formulas. Look, Na2CO3, sodium carbonate. You have 2 sodiums and 1 carbonate ion. This is like writing formulas for ionic compounds. Your compounds are neutral, which means that the total number of positive and negative charges, it has to be the same. When you look at your sodium carbonate, Na2CO3, the carbonate ion has a -2 charge. The sodium has a +1. For your compound between sodium and carbonate to be neutral, you need to have the same number of positive and negative charges. If the carbonate ion is -2, for you to cancel 2 negative charges, you need 2 positive charges. That's why the formula for sodium carbonate is Na2CO3. That subscript 2 is telling you that you have 2 ions of sodium. Each ion of sodium has a charge of +1. So you have a total of 2 positive charges. And then your carbonate ion has a total of 2 negative charges, which means that your number of positive and negative charges is the same and your compound is neutral. Now, when we go to the product side where you're combining the Na with the Cl, Na from the periodic table group 1 is +1. Cl from the periodic table in group 7 is -1. So you have an ion with a charge of +1 combined with an ion of a charge of -1. Same charge, it means that you don't need any subscripts in the formula. Subscripts are required when the number of charges is different. When you have +2 with -3, or +3 with -2, or +2 with -1. When the charge of the ions are different, then you need to use subscripts to cancel out your charges. Since Na is +1 and Cl is -1, you don't need any subscripts and you don't need those charges there either. Now, the second one is barium and carbonate. The charge for the ion of barium is +2. Group 2 in the periodic table, it's +2. Your carbonate ion has a charge of -2. So when you combine barium and carbonate to form your ionic compound barium carbonate, you need 1 ion of barium for every ion of carbonate, because +2 and -2, they cancel out. And you don't need any subscripts in your formula. So these are my 2 products from this reaction. Now you need to do other things. First of all, you need to balance the reaction. And you have to balance your reaction because on your reactant side you have sodium carbonate and it's Na2. You have 2 sodiums. And then on the product side you have sodium chloride. It's NaCl. And that's just 1 Na. So you need to use a coefficient to have the same number of every single element on both sides of your reaction. When I add that coefficient in front of NaCl, now I have 2 NAs, which is the same amount that I have on the reactant side. Now for carbonate, you have 1 on the reactant side and you have 1 on the product side. We move to the next reactant. For Ba, you have 1 on the reactant side and you have 1 on the product side. For your Cl on the reactant side, when Cl is combined with the barium, you have 2 of them. It's BaCl2. And then on your product side, when you added that 2 in front of NaCl, that's giving you 2 sodiums, which is what you have here. But that's also giving you 2 Cls, which is what you have right there. So every other coefficient should be just 1 and the reaction is balanced. Now another thing that you need to do, if I make sodium carbonate with barium chloride, my observations for that reaction is formation of a solid. If you have formation of a solid, it means that out of the 2 products that you're predicting from that reaction, one of them has to be a solid. So to find out which one is the solid, you need to use the solubility rules. If you check the solubility rules, anything that you combine with Na, which is sodium in group 1, it's always soluble. So now you can check your barium carbonate. Carbonates are listed as insoluble. You need to make sure that barium is not one of the exceptions. Your solubility rules are in the back of your lab manual. I'm finding the page. You have them in page 190. So your carbonates are listed as insoluble in your table, and you have some exceptions, which is group 1 and NH4. So when carbonates are combined with group 1 and NH4, they are soluble, but anything else combined with carbonate will give you insoluble compounds. So you can check your book in page 190 and you have your solubility rules listed there. The one that I'm looking at is the last one that you have in the table, where you have sulfides, carbonates, chromates, and phosphates. So when carbonate is combined with barium, that's insoluble, and that product should be classified as a solid. So if in your observations when you make sodium carbonate and barium chloride, you get to see a solid forming, the solid that it's being formed is the barium carbonate, because that's the insoluble one out of your 2 possible products. So let's do the second example that I have right there. So you have silver nitrate and you have barium chloride. Okay? So changing the ions, silver is the positive one, nitrate is negative, barium is positive, Cl is negative. So I'm going to do my Ag with the Cl. Just the ion, no subscripts are being transferred. You're combining just the symbol for the ions. Then you can check if you need any subscripts. And now what you have left is your nitrate ion, NO3, the nitrate polyatomic ion, and you have the Ba right there. So you have your 2 new combinations. This is that one, and the Cl with the Ag. So Ag plus, and then I have Ba with my nitrate. You're going to check if you need any subscripts, right? You have subscripts on the reactant side, but you're not transferring them. You're finding if you need any subscripts depending on which ions you're combining. Ag is +1, chloride is -1. So you have the silver ion is +1, the chloride is -1. Since you have the same charge, positive and negative, they cancel out and you don't need any subscripts for that one. Now, when you're combining barium with the nitrate, barium in group 2 is an ion with a charge of +2. Nitrate, your polyatomic ion nitrate, has a charge of -1. So if you have +2 and -1, you don't have the same total of positive and negative charges. So to make these numbers the same total of positive and same total of negative charges, you need to increase the number of negative charges. You need 2 negative charges to cancel out your 2 positive charges. So to get 2 negative charges, you need 2 nitrate ions. If you have 2 nitrate ions combined with barium, that will give you a neutral compound. Barium is +2, and then your nitrate is -1. But since you have 2 of them, 2 nitrates is 2 negative charges. Now the total number of positive and negative charges is the same, and that's the correct formula for your compound barium nitrate. So you can erase the charges because now your charges are canceling out. +2 with 2 negative charges, they cancel out and you have your neutral compound. So you have your 2 products that are forming when the ions are being exchanged. So you have an actual double displacement reaction, okay? Exchanging all of the ions. Now you need to balance the reaction. You cannot balance the reaction until you're done writing the correct formulas for your products. So I have 2 nitrates here, and on the reactant side, I have 2 nitrates. You need 2 nitrates to cancel out your +2 for the barium. So on the reactant side, you have just 1 nitrate combined with the silver. So to make your number of nitrates the same, you need to put your coefficient 2 in front of your silver nitrate. Now the number of Ag is increasing also because that 2 in front of AgNO3 is changing the number of Ags and the number of nitrates. You do have 2 nitrates on the reactant side, you do have 2 nitrates on the product side. Now you have 2 Ags on the reactant side and you need 2 Ags on the product side. So you need to put a 2 in front of AgCl. And then your barium, it's just 1. So you have 1 on the reactant side, 1 on the product side. You don't need to change anything in front of a BaCl2. And you don't need to change anything in front of BaNO3 too. Okay, that coefficient remains as 1 here and 1 right there. So you're writing your products, you're balancing the equation, and then the last thing that you have to do is check if a solid is forming. You need to identify which one is your solid. If you mix your solution of silver nitrate and barium chloride, when you combine your 2 solutions, you will observe the formation of a solid. That's your observation, formation of a solid. Now, when you write down the products of your reaction, out of your 2 possible products, you need to identify which one is the solid that you're observing when you're doing the experiment. So again, you can check your solubility rules in page 190 in your book 190. So if you check your solubility rules, your chlorides are listed as soluble. Okay? Any positive ion that you combine with chlorides, Cl-1, it's soluble, with the exception of those chlorides that are combined with silver, lead, or mercury. If you have silver combined with chloride, that compound right there, it's insoluble in water. So your AgCl, that corresponds to the solid that you observe when you mix silver nitrate with barium chloride. Now you can check your solubility rules for the second one just to make sure. Look, barium nitrate. Nitrates are listed as always soluble. Your nitrates can be combined with any positive ion, and that combination that you get will always give you a soluble compound in water. So that BaNO3 right there, it's an aqueous substance. It's soluble in water, and I should have the same thing for NaCl right there. So you're combining your ions, you're making sure that the formulas for your new compounds are correct by balancing the charges that you have. You're using subscripts to balance the charges, your positive and your negative charges. Once you have your products, the formula of your products, you need to balance the overall reactions. Once you have your reaction balance, you need to find out, okay, in my observations, I have formation of a solid. So let me use the solubility rules to identify which solid is the one that I got when I mix these two solutions.